Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 7th, 2025, so just about 4 days ago. This paper introduces a new training framework that boosts model performance by up to 9.0% on tough generalization benchmarks. The paper is titled INFI GUI G1, Advancing GUI Grounding with Adaptive Exploration Policy Optimization, and it tackles a really common problem for AI agents that try to use apps just like we do. The researchers found that current models often get stuck in a confidence trap, repeatedly trying an incorrect action, so they developed a new method that encourages the AI to explore more options, especially when it's struggling with a task. Also, the authors shared their official repository, and it's quite complete for anyone wanting to test this out. You'll find the evaluation scripts, detailed instructions for reproducing their benchmark results, and even the download links for the 3B and 7B models. The training code is on the roadmap for now. And over on Hugging Face, you can find both the 3 billion and 7 billion parameter models available for download, complete with code examples to get you started. Alright, so to really understand the problem, let's look at how these AI agents can fail. This figure breaks down the two main failure modes in what's called GUI grounding, which is simply the task of connecting a language command to the right spot on a screen. The first type is a lack of spatial alignment, shown here at the top. The model knows to open the camera app, but it's just not precise about where to click. The second, more critical failure, is a lack of semantic alignment, shown below. Here, the model precisely clicks the search bar, when it should have clicked the camera. It completely misunderstood the meaning, and this is the core problem the research tackles. So to solve this semantic alignment problem, the authors created a clever reward system called the Adaptive Exploration Reward, and these graphs visualize how it works. The chart on the left shows that the model is rewarded most when it finds the correct answer with a high rank, essentially being both right and confident. Building on that, the chart on the right shows how the system adapts its strategy. Successful attempts get a higher reward for being efficient, using fewer guesses. But when the model fails, the penalty gets smaller as it tries more options, encouraging it to explore more. This diagram really puts it all together, showing a side-by-side comparison. The top path shows the naive single answer approach, where the model gets stuck on a wrong guess. It keeps trying the same incorrect action, so the learning signal vanishes, and it never improves. In contrast, the bottom path shows the new multi-answer method. By generating several options, it breaks the cycle and has a much better chance of finding the correct action, which produces an informative learning signal for genuine improvement. Moving to the results, this table shows a head-to-head comparison on the MMBench GUI benchmark. The key comparison is at the bottom. We can see the new INFI GUI G1 models significantly outperform a baseline trained with a simpler method called reinforcement learning with verifiable rewards, or RL versus R. For instance, the new 7 billion parameter model boosts average accuracy to 80.8%, a solid improvement that highlights the real-world effectiveness of this new adaptive exploration strategy. This table then details an ablation study, which is where the researchers test their full model by removing one component at a time to measure its importance. Looking at the 7 billion parameter model, we see the full system achieves nearly 52% accuracy. But when you remove the collinear penalty, the accuracy craters to 37%, and the model starts guessing wildly, generating over 8 answers on average. This clearly shows that every component is crucial for smart, efficient exploration. To really validate the core hypothesis, the researchers split the test data into easy, middle, and hard samples. While performance improves across the board, the most significant gains are concentrated on the hard subset. On these critical samples, the 7 billion parameter model achieves a relative improvement of over 60%. This provides direct evidence that the new adaptive exploration strategy creates learning signals for previously unlearnable tasks, addressing the fundamental limitation they set out to solve. So in conclusion, the core takeaway is that by intelligently encouraging models to explore multiple answers, especially when they're stuck, this new method helps them solve those really tough semantic challenges that were a major bottleneck before. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.